Hi everybody, it's Armin. Today we're going to be doing some fan testing on NA Miata fan stuff. So I've got myself an NA Miata Koyo radiator here, as I keep a bunch of these Miata radiators on shelf. We're using this for testing. So I have a set of NA fans in the back here, as you'll see, just your regular old NA fans. And they are hooked up to two separate power supplies, so we'll be able to measure how much amperage they pull, and we'll be able to keep them at 12.7 volts, as that's what I tested the fans yesterday on for the NC Miata, so we'll just keep on testing at that voltage. And we'll be using my anemometer again, and we're going to be measuring in another grid pattern just like we did the last test. These are 2-inch grids all the way across. We're going to measure fans air speeds at each one of these points. We're first going to do stock fan system as it is, then we'll tape it up really well, weather strip it up really well, and see how much that makes a difference with stock fans. Then we'll do both of my fan systems that I'm developing. So one of them is going to be a lower power setup that hopefully is a decent improvement over stock, and then the other one is going to be a higher power system that may require you to put a PWM system in your car. If you're familiar with PWM systems, it's when you're able to pulse width modulate, control your fans so they have maybe not full power right off the bat. They're able to roll in, or they're able to be, let's say, turned on at, let's say, 50% for a certain temperature, and then they will ramp up to full speed whenever necessary. That's pretty cool stuff. That usually requires aftermarket ECU. So that's a whole other topic. Today we're just going to be testing this as well as the other stuff like I mentioned. So let's go ahead and dive into measurement. So my handheld anemometer measures in meters per second. You can change the units, but I did my last test in meters per second, so I'll just keep it in meters per second. First, I'd like to demonstrate that there's no cross flow of air across here. We do have shop fans going, but as you'll see, we have a value of 0. The little spinner fan is not moving. So we're not going to be having any interference from external sources. Next, let's go ahead and see what our base fan amperage is. So I'm going to turn on, this is the AC fan. It pulls about 3.15 amps at 12.7 volts. And the main fan pulls looks like it's varying between 7.1 and 7.2. So let's go ahead and say 7.2 amps. Now let's commence with the measurements. Alright, our first round of testing is done. Written down all my numbers. Now we're going to go ahead, dismantle this, weather strip up and tape up all the edges, and see if we can get some improved numbers for these fans. Well, I've gone through and I've taped up the entire perimeter. I've taped up the section between these fans. I believe these fans are pretty well sealed. Well, looks like I've missed a little hole there. I'll put a piece of tape on that. Then we're going to run this test again. Okay, we now finished our second round of testing. It actually looks like we had significant improvements across the board, but we'll review that after we get this back into the spreadsheet. So now I'm going to go ahead and hook up my first fan setup, which is going to be the one large fan and the one medium fan. Alright, now set up for our third test. Let's go ahead and get our amperages off of these things. So actually operating this fan, that one's operating this fan. So it looks like this one's pulling 10.2, 10.3 amps. Let's go ahead and call it 10.3 amps. This one's pulling about just shy of 6.4. We'll call it 6.4 amps. All right, let's get to measuring. All right, we've completed our third round of testing here. So, it's actually lunchtime for me. I'm gonna go take a lunch break. When I come back, I'll put on the bigger fan assembly, which is 2 large fans instead of a large and a medium. And we'll see how that performs. After that, we'll go through all the results and we'll see what we got. All right, we're back with our next fan setup. This is our last test. So this has my 2 larger fans on here. First, we're gonna see just how much amperage we pull off of both of these. I did notice that at 12.7 volts, this power supply, ironically my more expensive, fancier one, it only goes to 10 amp output, and that seems about where our output was on this one. This is a much cheaper one that goes to 11, but for some reason it, I don't know, it doesn't have the problem. Anyway, so just like the previous test, this should still pull about 10.3 amps. And we'll go ahead and turn this one on as well. So we're currently running at about 10.4 it looks. And this one's at about 9.7. Realistically speaking, they should both be exactly the same, but like I said, this one is gonna start pulling back because its limit is 10. So yeah, it's at about 9.7. It's struggling to get close to 10 because of the safeties built into it. So anyway, we're gonna go ahead and do our measurements. All right, so that concludes our last test. Let's over to the computer, enter all of these numbers, and see what results look like. All right, now that my assistant's here, we can go over our results. So, I actually am really happy with these results. They demonstrated about how I had expected, not numerically, but I mean just difference-wise. So, I think it's a really fun experiment when you actually show some good results. So, let's go over all these. Up here on the screen, we've got the stock NA fans. So as you'll notice on the left side, which is the passenger side where we have our AC fan, it flows significantly less, which we already knew because it's a smaller fan, it's a lower power fan. Contextually speaking, it should flow significantly less. Our max was a 4.9 and our minimum was a 2.2. As you'll notice, the entire right side is all of our greens and our lime greenish colors, and the left side is all of our reds and our yellows and oranges. So let's go ahead and see what difference it made to seal these fans up. Because again, I go through the effort whenever I do a customer's build. I seal those fans up because again, on the engineering side, if you're not sealing your fans up, then you're probably not getting all the airflow through the radiator. So as shown, you'll see that all the numbers got pumped up. We saw an average difference of 0.27 meters per second across the whole face, which I'd say is reasonably significant. I mean, for some free airflow, that seems pretty good. And you'll notice I have the delta over to the right side here, and that's just the difference per cell or per location of measurement as to where the greatest differences were. What sticks out to me about these results is that you'll notice on the outskirts and of the AC fan, you'll notice that we had an increase of flow in those spots. So apparently there was air escaping around the edges and not being pulled through the edges. So by sealing it off, we were now getting airflow around the edges of the fan, which is pretty cool. And in the center, it looks like we made maybe some minimal differences around where the center of the fan is, because the fan's going to focus on pulling air from the middle. Now, let's move over to seeing what my lower fan system does. As you'll recall, I said that we were using a large fan on the right side and a medium fan on the left side. So as you see right off the bat, this one pumps right up to an average versus the sealed up NA fans. We were seeing an average of 0.82 as our increase in meters per second across the board. The maximum difference we saw was 1.6. But as you'll see by the deltas here, that's quite a bit of improvement. You'll also see that the distribution of all of the airflow definitely biases over to the right side on this one. I mean, it has very, very good consistent numbers over on that right fan. And the left side, yeah, it is red and orange because it's lesser than the right side, but those numbers are still all about the medium fan that I was putting on is about the size of the stock main fan, it would seem. So let's move down and look at the final fan setup, which was the 2 large fans. So the 2 large fans obviously should flow the most, and they do. I have the delta shown here for that versus my other fan system for comparison. But if you really wanted to get down to the comparison, the stock sealed fan system versus the bigger 2 large fan system, we saw a 1.31 delta average across the board. So 1.31 meters per second is pretty significant. I mean, that's what, over a 30 or 35% difference compared to the stock fans sealed up. So I think this goes to show that my fan system's going to work pretty well. I'm looking forward to being able to release these. The next step that I'm going to go through is going to be some experiments with seeing how to make them work well in the car. So a brief discussion about that. I had mentioned PWMs earlier, and I want to explain a little more about that. But first, let me explain the necessity where PWM comes in. So whenever we've installed larger fans on a customer's car, because I mean, I've done these fan setups before. Someone brings in a set of Mishimoto fans and we go, oh, well, these don't flow that great, and we know it. I don't have the experimental data to back it up other than the part of some people do have some temperature issues, and then when we upgrade their fans, they suddenly don't. But we've put in some of these larger fans, and the problem is some of the cars will die at idle if you put too big of a fan. The amperage inrush, as we call it, the spike of amperage to turn the fans on can be so great that when your AC kicks on at idle, the load of the AC and the load of the electrical inrush shuts down the car. There's just not enough electricity to go around. So what I've done in the past is we've either had to raise the idle to, avoid that dip to where it can't stay alive, or we do a lot of additional power, let's say power support. So we'll add a dedicated 4 gauge all the way from the battery all the way to the alternator, and then daisy chain that over to the fans. And that can help. But we still have the great inrush. The fans will still demand a lot of power, so it may get it to do it a little bit less often. You may not have to raise the idle as much, but you still have the issue of the inrush. So that's where the PWM system comes in. These fans can be controlled by pulse width modulation. And what that means is instead of it just being 12 volts the whole time, it's pulsing, let's say a 12 volt signal. It's able to pulse that, so that way the fan operates at a lesser speed. So a 50% speed would be, using the pulse width that fires a 50%, I guess you could say duty cycle, if you will. That might not be the correct terminology, but PWMs are something that I'm getting more familiarized with because we've gotten a couple of units in recently. We've started using them. So aftermarket ECUs such as the Megasquirt have an output where they can supply a pulsed output to control something like a PWM controller. And then the PWM controller sees that input and it goes, okay, cool. I will send a pulsed input to the fans. This may get you to ask, now why don't we just have the Mega Squirt or aftermarket ECU directly pulse the fans? And the reason is, devices like the Mega Squirt, let's say they have a up to 100 hertz type output, or whatever theirs is. I want to say it's like a 100 hertz thing. They're able to send out their frequency of command at 100 hertz. Well, the types of fans we're using will operate in a 14 kilohertz range. So that means they're nowhere close to the same, let's say, language. So what will happen is, within the PWM controller, you're able to set a lot of additional parameters, and you're able to have it take in that 100 hertz signal and interpret it to give a 14 kilohertz signal to the fans. That and the unit itself, the ones that we're looking at using they're self-contained. They have a bunch of other additional features, such as like an override, where you can have an AC override and it'll just automatically take that signal in. So if your ECU, let's say it's inconvenient for you to wire your ECU to turn on at full speed for the AC. Let's say the AC is its own independent component on the car. You can have that as an input into the PWM unit, and the PWM unit will see the override and go, oh, 100% speed, and then kick your fans up. But that's a whole bunch of other topics. I'm going to do a bunch of testing. We want to see just what we can recommend our fans to be used for, and we want to make sure that when you buy the product that, of course, you install it and you're happy with how it runs. Currently, I'm happy with the design of physically how they fit, how the fans work, all of that. So I'm looking forward to releasing these soon. I hope you guys enjoyed all the data. I hope you watched the other video of the NC Miata fan experiment, and I hope you stay tuned for further experimental data. Thanks for watching.